Welcome back. In this session, we will dive into the fascinating world of some of the most complex and threatening waste types currently in existence. At the end of this session, you should be able to identify the different waste fractions, understand key issues and challenges related to each waste type, describe the basic principles of management of each fraction, and recognize the importance of transboundary waste movements. When is a waste hazardous? According to the Basel Convention, the convention controlling transboundary movements of hazardous wastes and their disposal, hazardous wastes are any wastes that possess any of the following characteristics: explosive, flammable, combustible, oxidizing waste or waste containing organic peroxides, poisonous, infectious substances, toxic or ecotoxic, and corrosive. All these characteristics are explained in Annex 3 of the Basel Convention. Hazardous waste can come from industries, such as chemical manufacturing, petroleum and coal product manufacturing, mining activities, pulp and paper industries, pharmaceutical industries, etc. Small-scale businesses can also generate hazardous waste, which might be part of the municipal solid waste stream. Examples of such businesses are car workshops, leather tanning companies, and photo finishing shops. But hazardous waste can also be produced at home. For example, cleaning agents that are highly corrosive, batteries and cosmetics, such as hair dyes, that are toxic, waste oil that is flammable, without mentioning pesticides, pharmaceuticals, refrigerant-containing appliances, varnishes, and e-waste. The management of hazardous waste has become a specialized discipline. We will use this simplified diagram to explain the main concepts. Let's start with prevention or minimization. This can be done by the product manufacturers by reducing hazardousness, for example substituting toxic materials with less toxic materials, and reducing amounts by modifying manufacturing processes to follow green chemistry, increasing efficiencies, and establishing new business models such as chemical leasing, which implies renting out instead of selling chemicals. Prevention can also be implemented by influencing consumers' behavior to choose products which do not contain hazardous materials. After initial consumption, and before the product turns into waste, materials can be reused. Then, the materials we refer to as waste are generated. It is imperative to source segregate all this waste, especially hazardous waste. Waste needs to be stored. This can be done by using small containers, but keep in mind to always label it, indicating your name, the content, the physical state, date of first and last deposition, as well as the amounts and codes of hazard category. The environmentally sound management of hazardous waste consists of several steps. First, the materials go through a pre-processing stage, where the hazardous elements are either separated, immobilized, or degraded. These methods can be classified into physical, chemical, thermochemical, and bioremediation methods. These materials can then be stored again until they are either recycled, processed through other recovery options such as energy recovery, or finally disposed of, following the waste hierarchy. The Basel Convention includes guidelines for an environmentally sound management of numerous waste streams. Go on their webpage to check it out. Toxic Waste Routes is an interesting project which tries to visualize both imports and exports. By clicking on the top of a country, Germany for instance, we see the amounts of hazardous waste exported in red and imported in light orange. Each box represents an importing or exporting partner country, and by putting your cursor on top, you get more detailed information about the nature of waste and the specific amount. Now let's talk about healthcare waste. First and above all, you have to realize that healthcare waste comes from many sources, including major sources such as hospital, clinics, and laboratories, but also minor sources such as doctor offices, dental clinics, and convalescent homes. If we look at healthcare waste amounts and composition, only 15 to 25% of the healthcare waste, only this fraction, is actually hazardous. The rest is actually similar to municipal solid waste, and can be treated the same way municipal solid waste is treated. Segregating this hazardous fraction from the rest is the most important, because this part needs a very special treatment. The environmentally sound management of healthcare waste consists of several steps. First, the waste should be separated at source according to the level of infectiousness and hazard. According to the WHO recommendations, waste should be segregated as follows. Sharps waste such as needles, syringes, but also blades should be put in a yellow puncture-proof container, marked with sharps and with biohazard symbol. Highly infectious waste, such as diagnostic laboratory samples, and waste from infectious patients in isolation, in a yellow strong leak-proof plastic bags or container capable of being autoclaved, with biohazard symbol, and marked with highly infectious. The container should then be autoclaved. Infectious waste, such as anatomical waste, in a yellow leak-proof plastic bag or container with the biohazard symbol. Non-infectious waste, or general waste, should be put in a black plastic bag or container. Once waste is segregated, the normal non-infectious waste, it should be simply disposed of as any other municipal waste. However, infectious waste should be treated first, and then disposed of. Common treatments are sterilization, done with autoclaves, steam or microwave systems for sharps, materials with blood and body fluids, gauze, bandages, cultures and stocks, or dry heated, which is commonly used to treat small volumes. Chemical disinfection using dissolved chlorine dioxide, bleach, lime solution, ozone gas, or incinerated in a proper incinerator. The Compendium of Technologies provides all the information regarding which treatment technology to use in which case and context. Now let's talk about e-waste. Electronic waste, or e-waste, refers to all items of electrical and electronic equipment (EE) and its parts that have been discarded by its owner as waste without the intent of reuse. The definition of e-waste is very broad and covers 6 waste categories. Temperature exchange equipment, screens and monitors, lamps, large equipment, small equipment, small IT and communication equipment. Considering the numerous applications of all electronic items, it is not hard to imagine that the composition of e-waste is very diverse. In general, it is characterized by containing a combination of metals, such as steel or aluminum, plastics, glass or other substances and materials, or even a mix of materials. It also contains hazardous materials, heavy metals such as arsenic, mercury, lead, cadmium, and chemicals, such as chlorofluorocarbons used in cooling units, polyvinyl chloride used as cable insulator, or various flame retardants. Despite the high toxicity of e-waste, its market value is quite high. Among the substances of interest are a very wide range of metals, including rare earth metals, such as lanthanum, cerium, praseodymium. Precious metals such as gold, silver and platinum, or other metals such as copper, aluminum or iron, which have together with plastics from used covers, a high intrinsic value. It is this very same high intrinsic value, and the high cost of e-waste recycling that makes e-waste traded worldwide, leading to big environmental and human health threat, as we will see later on. The e-waste generated is usually collected in either one of the 4 following schemes. The official take-back system. Here e-waste is collected by designated organizations, usually under the requirement of national e-waste legislation. The final destination of collected e-waste is a state-of-the-art treatment facility, which recovers the valuable materials in an environmentally sound way. This is the ideal scenario, aimed to reduce the environmental impact. Mixed with residual waste. Here, consumers directly dispose of e-waste through normal dustbins with other types of household waste. As a consequence, disposed of e-waste is then treated with regular mixed waste from households. Depending on the region, it can be either sent to a landfill or municipal solid waste incinerator, with a low chance of separation prior to its final destination. Neither option is regarded as an appropriate technique to treat e-waste, as they lead to resource loss and have the potential to negatively impact the environment. Collection outside official take-back system. The third collection scheme involves collecting e-waste outside of official take-back systems. In high-income countries, e-waste is also collected by individual waste dealers or companies, and then traded through various channels. This waste is usually not reported, often not treated appropriately, and possibly shipped off to low-income countries. The export of e-waste is motivated mainly by two reasons. First, often inexpensive second-hand equipment and raw materials are demanded in low-income regions. Additionally, as the cost of waste disposal skyrocketed in high-income countries, shipping e-waste to regions with less stringent environmental regulations is cheaper. After informal collection, e-waste can either be sent to a recycling facility, but is mostly recycled through backyard recycling, which can cause severe damage to the environment and human health, from open burning to extract metals, acid leaching for precious metal, unprotected melting of plastic, and direct dumping of hazardous residuals. This map shows the global trade in e-waste. In this map, the arrows show the flows of e-waste. The exporters of e-waste are typically Western European countries and North American countries, whereas many countries in Africa and China have been common destinations for such exports. Now let's move on to plastic waste. Plastics account for a very large proportion of the waste we produce and represent one of the waste fractions with the lowest recycling rate. Since the 1950s, when plastics first appeared, we have produced approximately 6,300 million tons of plastic. Plastic is a term used to define different types of polymers, which are generally divided into 7 categories: PET, HDPE, PVC, LDPE, PP, PS, and more. Not all of these plastics are easily recyclable, and the recycling process can only be done with the same polymer. Some plastics are biodegradable, some are not, and a new type of plastic so-called oxo-degradable. Let's have a look at what biodegradable and oxo-degradable mean. Biodegradable means that the material can be broken down into water and CO2 by natural organisms over a short period of time. Contrary to popular belief, the biodegradability of a product does not depend on the nature of the polymer, whether we are talking about a plastic of fossil origin or a plastic of biological origin. Biodegradability depends on the chemical structure of the material, its thickness in particular, as well as environmental conditions such as temperature, humidity, and oxygen. Nowadays, in the global plastic market, there are very few biodegradable plastics. This diagram shows different types of plastics, classified according to their origin, if they are bio-based or fossil-based, and their level of biodegradability. Here we can see that conventional plastics such as PE, PP, and PET are of fossil origin and not biodegradable. We also see that some plastics such as PBAT, PCl, falling under the category 7, are of fossil origin but indeed biodegradable. And that on the other hand, some PET, PE, PA, and PTT plastics of biological origin are not biodegradable. Oxo-degradable plastics are different, and therefore not represented here. Indeed, oxo-degradable plastics are conventional plastic with additives to mimic biodegradation, which leads to a fragmentation of the plastic. A PET bottle, for instance, could be oxo-degradable, which would mean that this PET bottle could be fragmented in very small pieces, called microplastics, not even visible to the eye. Now let's talk about plastic waste management. The best plastic waste is the one never generated in the first place. To prevent plastic waste generation, interventions can be done at both the manufacturing level and the consumer level. Once plastic waste is generated, a huge effort should be put on minimizing the unmanaged plastic waste. First and foremost, providing effective waste collection and disposal should be prioritized, especially in low and middle-income countries, to stop the leakage of plastics into the environment. Managed plastics could either be reused or disposed of, and resources from the material could be recovered. Here, we distinguish three types of recovery options: material recovery, organic recovery, and energy recovery. Now let's talk about construction and demolition waste. We all have probably witnessed the demolition of a building, or some sort of infrastructure. Have you ever thought about what happens with all the debris? Can it be reused in one way or another? That is what we are going to see now. In order to understand the generation of construction and demolition waste, let's first have a look at the life cycle of a building or a civil engineering structure. After the design phase, buildings or civil engineering structures, such as streets, highways, bridges and subways, are constructed, for which energy and materials are consumed, and construction waste is generated. Construction waste is normally composed of surplus, damaged or broken material, packaging, garbage generated by the people on the construction site, soil and sand from site preparation, and so on. This waste could be recovered or disposed of. Renovation, reconstruction, or repair might be required throughout the life cycle of the infrastructure. This again requires energy and materials, and generates both construction and demolition waste, which is comprised of all the previous materials, as well as rubble and mechanical equipment. Once more, part of this waste can be recovered or disposed of. Finally, demolition can result due to both natural disasters and man-made causes, such as civil conflicts and vandalism. Demolition produces a significantly different waste than construction or renovation. Demolition waste is composed of mixed rubble and debris, including wood, concrete, reinforcing materials such as steel, which can be contaminated by undesirable components and/or potentially hazardous substances such as lead paints, stains, and adhesives. This waste has traditionally been disposed of but can also be reused to substitute virgin materials. Now let's see how to improve CDW management. CDW waste prevention measures can include reducing the overordering of materials, and also designing for deconstruction, so that material could be reused more easily. Due to the variety of waste materials, it is important to segregate construction and demolition waste. This can be done at source, ideally, or in specialized treatment plants. We are done. Let's summarize what we've heard about in this session. We saw different special waste fractions: hazardous waste, healthcare waste, e-waste, plastic waste, and construction and demolition waste. For each of them we saw where they were produced and their specificities. We saw the importance of waste prevention and waste segregation as key elements of waste management. We saw environmentally sound management for each of them. And finally, we also saw transboundary waste movements. Thank you for listening. See you in the next session.